Thought that Mars didn't have any microbes, and I think in the movie didn't they use human waste? Is that a little bit of a problem, right? I mean, there are all sorts of pathogens in there, right?
Yeah, and frankly speaking, right now, if I say, okay, are there no microbes available in the soil of Mars? We didn't get a direct evidence, but I won't rule it out. All because right. Microbes are known to if water is around, they're known to flourish, they're known to grow and divide in very, very adverse conditions. So right now, probably we don't have that evidence for that. Yes, what is shown in the movie is that there are not microbes available. So what this guy gentleman did was to use human waste, and using it directly will be a problem because different persons have different pathogens, different microbes, and that may cause some problems, some contamination. So human waste needs to be treated to make it suitable as a manure. And on Earth, it happens naturally. The human waste or the animal waste, the way the microbes are, they work on it and convert it into a useful manure. So on Mars, how you're going to do it? One way, and the research is there, is treating those human waste with radiation so that you can convert that into a useful manure. You can do that. So as far as the microbial diversity is concerned, we can work around that. But the biggest hurdle which could come from some of the things which are there in the soil, which may be toxic to the plant, and toxic to human also. And that major chemical which may be responsible is the perchlorate. And the perchlorate is a very unique molecule, and it's a molecular ion. It has a negative charge associated with it, and it is present on the soil in the form of calcium perchlorate. And the water, we say water on Mars is not available as it is available on the Earth. It's available in a very concentrated form. It's actually a very concentrated brine, and it has a very high concentration of calcium chlorate. Because the physical properties of the calcium chlorate allows it to dissolve into water to a very large extent. So calcium chlorate, I have brought this model here. This is the chlorate ion. In chlorate ion, you have a calcium in the middle, and there are 4 oxygen atoms which are directly linked to the chlorine, in fact, not calcium. This is chlorine here. And there is a negative charge which is uniformly dispersed on all the 4 oxygen atoms. So that makes this ion very, very stable. So when you dissolve this ion in any solvent, even in a solvent with a very low dielectric constant, it gets completely dissociated. So you have the metal ion and you have the chlorate ion. Metal ion, most of the metal ions, they're heavily hydrated and they have a high hydration energy. But as far as the chlorate ion is concerned, because it's a big molecule, it has a very low negative charge density. And that's the reason it is weakly hydrated and it has a very low hydration energy. So that makes it a very, very a unique molecule. On Earth also, we have some areas where we are dealing with high concentration of perchlorate in the natural aquifer, which is toxic. So we need to tackle this issue if we want to use Mars soil for growing the plants.